Good morning everyone. We are students of KLE Technological University, Hubli. We are working on engineering exploration project under the guidance of Jyoti ma'am. I am Sanchit with my teammates Yash, Karthik and Sachiket. Problem definition. Design a self-balancing system that is capable of balancing an object on it and must be locomotive. The system must be controlled manually and it must be user-friendly. The system must contain battery backup. The system must cost around 3000 and must weigh at most around 1 kg. The system must be able to work continuously for around 3 hours. The product must be ready to be delivered within 3 months. The size and the dimension of the system must be 25 by 15 by 20 centimeter. The system must be able to balance an object weighing at most 100 grams on it. The system must contain some LED lights on it. Function tree and functioning clusters. We have divided our self-balancing system into 3 units. The balancing unit consists of balancing the platform, balancing the body. The movement unit consists of forward movement, backward movement, turning around, stopping. The user acknowledgement unit consists of indication of LEDs. The subsystem identified are motional unit, balancing unit, user acknowledgement unit. Based on 3 subsystems identified, we have generated 4 concept designs. Out of the 4 concept designs, we have selected our concept by taking the help of the puck chart. The selected concept is the design 2. Since platform is directly attached to the servo motor, frame which supports servo motor and material of platform are standard one and are easily available.
I'm Karthik. I'm going to explain about the 3D model of the entire system. Our entire system is divided into two main subsystems. One is the motional unit and second one is the balancing unit. The motional unit consists of 4 DC motors, each of 30 RPM, which are controlled through relay modules via Bluetooth using Bluetooth module HC50. And it also consists of a Arduino Mega 2050 microcontroller. The main function of the motional unit is the movement of the entire board in either front and backward direction or in left or right direction. Now moving towards the balancing unit, the balancing unit consists of 2 servo motors. One is to rotate in X direction and another one is to rotate in the Y direction. And it consists of a balancing platform. It is the main platform over which we are going to keep the object which is to be balanced. And the balancing unit consists of MPU6050 sensor, which is accelerometer and gyroscope.
I am Sachiket, roll number 950. So this is the circuit diagram of our entire system. It contains an Arduino Mega 2560 board which is connected to 4 DC motors through motor drivers via breadboard and is also connected to MPU6050 which is a 6-axis motion tracking device and through which it is connected to 2 servo motors to balance the platform. This is the flowchart of the entire system. The left flowchart is for the motion unit and the right flowchart is for the balancing unit. So in the flowchart of motion unit, first the input is given to the Arduino and according to input, signals are given to the DC motor. Only if the switch is on and according to it, motor starts moving in left, right, front and back direction. In the flowchart of balancing unit, first the platform inclination is checked whether it is balanced or not. If it is balanced, the control sends commands to servo motor. If it is not balanced, it checks the inclination of platform. If the inclination of platform is backward, it gives command to servo motor to rotate in forward direction and vice versa. Similarly, if the inclination of platform is in right direction, the controller gives commands to servo motor to rotate in left direction and vice versa. And this continues until the platform is balanced and the speed of which is controlled by an accelerometer. So this is the bill of materials required for the entire system. These are main body which is made up of foam sheet, 4 DC motors, 2 servo motors, 1 Arduino Mega 2560, 4 rubber wheels of 9 cm diameter, 1 breadboard, male to female jumper wires, balancing platform made up of acrylic sheet, supporting rods of steel, MPU6050 sensor. Now coming to the motor sizing and battery. So here torque is given as force into radius. Here weight of the bot is 2100 gram and radius of wheel is 4.5 centimeter. So the calculated torque is 2.1 into 4.5 kilogram centimeter is equal to 9.4 kg centimeter. So for 4 DC motors it comes out to be 2.3 kg centimeter. So we need 4 DC motors of torque 2.3 kg centimeter. Functional specification of entire system. We have identified two functional specifications, that is motional unit and balancing unit. And based on that, we have identified three interactions, that is material, data and spatial interaction. Motional unit, balancing unit, material interaction. Both units are attached to one another by four thread routes at edges of each platform. Spatial interaction. There is 2 degrees of freedom for the balancing unit and there is linear motion of the bot. Balancing unit, motional unit, material interaction. Both units are attached to one another by four threads at edges of each platform. Special interaction. There is 2 degrees of freedom for the balancing unit and there is linear motion of the bot.
My name is Yash Kulkarni. I am going to present before you modeling and simulation part of the movement unit. In this unit, the input to the system is given by an input parameter named constant and the output of the system is displayed using display parameter. Currently, the system is in on state, that is A equal to 0, which we can verify. Yes, it is in on state. When the input to the system is given as A equal to 1, the system moves in left direction, as well as when the input to the system is given as A equal to 4, it moves in right direction. When the system is given as A equal to 3, it moves in backward direction. Similarly, if you want to move the system again in front direction, you can give the input as A equal to 2. When you want to shut down the system, you can give the input as A equal to 5. For example, if you want to move the system in left direction, we have to give input as A equal to 1. Yes, as you can see, the left wheel is moving in backward direction while the right wheel is moving in front direction, which indirectly means that the system is moving in left direction. Thank you.